iOS is info p lists, property lists. So these XML formats, they maintain the type and the value and the key. So the type, key and value. So this checking of whether the type matches what I'm expecting is not required. It just gives you a list of everything.
Yeah, you probably could, but I think it would be, get it working first, and then you start to expand it. And the first thing you do is you get it working, then you start to write helper functions. You're like, man, I've written code to turn a table into a vector of 3 floats about 1 billion times, so I write a thing to do it.
Also, this maybe it seems like a lot of work because we're writing a lot of code, but it's still, we're assuming that it is much faster than parsing an XML file, for example, right? Because that is heavily string reliant, and this isn't.
Yeah, like I said, we're relying on the Lua people being honest in that they wrote something fairly efficient. And the guys I work with that did this, they wrote some test code, and they're like, well, it's within such a small margin of difference that it's not like it's slowing us down. And generally you don't do this stuff, you do it at load time.
Yeah.
And as we'll see in the next few weeks is, well, you just pass it off to another thread. We have one thread that does the I/O, that loads the file. It passes the file data off to another thread that parses the Lua stuff and creates the object, and then we pass it back to our main thread, and it takes the object, and so the main thread continues to run. When it needs to load data, it puts a Lua file name onto a load list, and just goes back to its work. Then the first thread loads the file. When it gets the contents loaded, it pushes the contents onto a data where another thread says, oh, I need to parse all that. I create an actor, and then I put it back into another list that the main thread actually, oh, look, there's an actor on the stack that I need to put into the game.
Oh, no, Lua has a way to load a file directly.
Yeah, but we don't. The problem with that is we don't have any control over what to do if the file is bad, or the disk. In the old days, with console games, you always had to handle the case where the disk was scratched, and so our file loading code was very bulletproof as far as handling scratched disks and stuff like that. And I mean, it didn't do error correction; it just handled it gracefully, where you don't know what Lua is doing under the hood when you hand it the file name. Plus, if you just hand it the file name, you don't get to handle it. You can't load that file threaded. You have to rely on it blocks. If you tell Lua, there's a Lua thing you say, hey Lua, load this file. You've got to sit there and wait. That's a block.
You could load the Lua files
in another
thread, and then pass the Lua states around instead.
Yeah.
Maybe.
Yeah.
You mean you had to handle when the disk was scratched? Or would you feel like this information is incomplete?
Yeah. Well, you'd have to detect. Well, what had happened is OS would tell you that there was a read error, and you had to figure out what it was. And you had to pop up a message and handle it semi-gracefully, Yeah, I don't know if you ever got the message. This disk is damaged or dirty.
It sticks the disk back out at you. That'll work.
We also had to gracefully handle if someone popped it, like on the old systems, if they popped the top open and they couldn't read anymore. So, and you got to handle it too. Like, yeah, you just, our file reading code had to be very robust. It didn't have to recover from that. It just had to recognize at any point during the process that a file was unavailable, just couldn't be read. So, and again, ideally, we talk about this next week or two. One thread handles file I/O, passes the stuff off to another thread that processes it, and so on, so that you don't want to have in your main loop accidentally fire off a file read, because they take time. So
500 milliseconds.
yeah. So any other questions?
So why we're comparing the result of Lua next with 0 instead of null or nil?
Because it just returns, I think, I'm not sure, it returns 0 if it couldn't do it. I think it returns 0 or 1. I don't remember what it is. You look it up there?
Yeah, I would.
But it's just telling us whether it succeeded or not. So, all right, well, we're going to walk through, so this is, we'll take a break now. This is my data file I've created, and I've got my sample that walks through parsing it. So, unfortunately, I can't get them both on the screen. So, let's take a quick break, burn that into your brain, and then we'll walk through my actual sample code. So we'll take a break till 8 o'clock. And then the rest will be quick and we'll be done.
Do we need to do like any type of shutdown as well?
I don't think so. If I do, it's in my sample, I think.
Okay.
Remember, open it up. Anyway, I don't think so though. Well, let me. You'll have to look in the docs for that. I don't shut it down explicitly, but because it is garbage collected, maybe, I don't know. That's a good question. All right, we'll get this done. So here's a data file I've created that just something I threw together to parse, and we're going to walk through the parse code I wrote, and it's available. I duplicated it over here. Hopefully you can read it, but I duplicated it over there so that once we bring up the code, you understand what we're working on. A couple things I wanted to point out here. One, you should notice that by the way we parse, way we query, we say, hey, give me this global. And then if we have a table on the stack, we can push a key and say, hey, find me this value associated with the key. What that allows us, a couple things allows us to do. First of all, we can completely ignore, we could add key values in here that if I added a key value, if I had a parser, a Lua parser, that parsed this whole thing by, getting the player, then pushing keys on the stack and finding them, I could add something to this, and my code wouldn't break, because my code's all query based. It doesn't expect anything to be anywhere. It just says, find me this, find me the name. I'll push the table player on it, I'll push the key name, find it for me. And it does that, it's all query based, so it won't explode if I change. Now if I change name to be 11, it might get mad. But if I add I have name equals Joe and I put last name equals Barnes, the parsing code's not going to blow up, because it needs to know the name, and if there's an extra step in, that's fine. The other thing is we can do here, I've broken this up. My main thing is player, and it's got a bunch of data, and then I've got within there I've got another table within that table, and here's a table called physics settings. What I can do is, if I push player onto the stack, if I push my player onto the stack, which I probably only need to do once, I push the player onto the stack and then I can query it until I'm done with it. But then I push physics settings as a key on the stack, and I say, Lua, get this from the table. If it doesn't find it, if there's no physics settings in here, I don't create a physics object or physics info for this object. And what that means is it doesn't need physics applied. Same with the render setting. If I don't add this block here, this table into my player table, and I look for the render settings and it doesn't exist, then I don't add a renderable to my render system. But yet I can still apply physics to it or whatever. So it allows me that flexibility. So anyway, I drew it over here. So once this is gone, we kind of understand what it is. I drew these little blue lines to kind of match up some of my tables, so we know how big the tables are. I thought it might help. I don't know. So anyway, so I've got the sample that's out there, and you can pull it down. And I'm going to try to walk through it. Sometimes doing these demos on the screen doesn't really work really well, because we don't get a lot of, there's not a lot of screen real estate. So let's just start it up here. Anyway, so I've got this thing that processes my player, and you can look at it later, but I've got another table that defines my monsters, and it's an array of just not as much information, but I was trying to do another sample. Anyway, so we're going to walk through this, and like you see, we're doing what we talked about here. We create our Lua state, and then we open our libs. I'm going to get rid of this because we don't need this. And I think that's about as much screen real estate as I can get. You guys can't see the bottom anyway. So anyway, I do what we talked about, where I load the file contents, and then I load the buffer, and then the first thing I want to do, because I'm processing the player, is I want to get the global that's player, and because it's in the global space, so I say do that, and then again get global returns me the type, whatever type it was. So I validate that when I asked for player that it wasn't a string, that it's a table at least. That's my first step of validation, that, you know, player equals 5 is not in there. So, and ideally here, what we really want to do, I assert on the value, but what we really probably want to do is you know, if someone inadvertently tweaks as to where it doesn't work, we probably don't want to assert. What we want to do is print out something to the log and then stop processing this file. But I did assert here, so anyway, all right. So we pushed it, that's on the stack now, and I'll try to keep up with the stack over here if I have room. So let's just say there's, you know, I don't know what's on the stack already. There should be nothing. Let's do that too. We're going to validate the stack when we're done. So our stack is at the bottom. And again, my stack pointer means the next place to write. So it puts the player table here. And then it bumps up the stack pointer, so it's at -1. And then the first thing I want to do, and I'm following the order of the file, but again, I don't have to do this. But I push the name, the string name, and I'm not going to walk, you know, I'm not going to single step all of these. And then I call Lua, so I push the string name because I want to find it, and I say, hey Lua, get me the table. Now the weird thing is even though, you know, like I said, everything's a table. Even though that's a key value pair, the key is named, the value is is a string, but well, anyway, we're getting it out of the table. So there I say, okay, get out of the table. The table location is -2. The key is implied to be at the top of the stack, and I get the table. And again, it's going to replace -1 the name with the actual, it's going to, get table is going to replace my key. This is the implied location of the key. It's going to replace my key with the value of the key at the key. And then it's going to return to me what type it put on the stack. And I'm going to validate that that was a string, because that's what I expect my name to be. Then, like I cut out of my samples, I'm going to grab it, I'm going to say, hey, Lua, I validated that it's a string, so I can call Lua to string, and it's going to work, and it's not going to inadvertently convert a float, because I validated it's an actual string. So I say, hey Lua, give me the value at the top, at this stack location. It doesn't have to be the top of the stack. I can say Lua, give me the thing at any location in the stack as a string. And so, but I know that it's at the top of the stack, which is -1. Give me that string, the value, to give me my actual name, Joe, and then I string dupe it, because again, I don't own that string. I just have a pointer to their data, so I string dupe it. Now I'm done with that. I've duplicated my name, and name should be Joe. Yeah, it's Joe, so that worked. So then I'm like, okay, we're done with that now. I'm done with that, so I pop it. And we go back to where we were. So my table is still on the stack. So now I want to get something else. So I want to get my initial position, which, see, I've skipped a few things already. Okay? Now, I want to get my initial position. Now my initial position there is where Joe was a string. The key value pair name of Joe was, the value was Joe, which was a string. I push my initial position key, and I ask it to get it, and so it replaces that with the value. Now the value of initial position is a table, because it's a table. Tables always start and end with curly brackets and have items in them. So now I validate that it's a table. I said, okay, I expected the position to be a table, so I validate that. Now, I want to read the 3 values in there as a vector 3, as 3 floats. And I got tired of writing the code, so what I've done here is I've written a read float array, and I pass in the state, probably the stack location of the value. So what I've done here is, I pushed initial position here. And it replaced that with the actual table. So I just wrote this routine called read float away, and I pass in the Lewis state the location of the table I want it to convert an anonymous table of floats into a three float array. So I pass in, I've written this read float away that takes the state, the location, the output, and how many items there should be. So we'll walk through that. So I just validate that, you know, everything's coming in as kosher, that I pass in a valid non-null state, that my index isn't out of range, and that the type of the thing I'm supposed to parse, because I pass in the index I pass in the location of the stack that I want converted to a float array, and it makes sure that it's a table. Because that's what it converts to floats, is a table. So then, again, we're going to use that whole iterative approach because they're anonymous values. So I push a nil. I call Lua next, which I pushed nil, which was my first key. And it replaces it with the actual key, which would be 1, and then the value, which should be 1.0. So it's increased the stack. So now my stack is actually 4 deep. Okay. So I want to validate here that that the type is right. That the actual thing on the top of my stack, which is my value, is a number. That because that's what I'm converting. So I said, make sure that the top value is a number. If it is, you know, then write it out to my output array. And so again, I validate that that top item is a float. Then I want to get it, so I say, hey Lua, give it to me as a number, this item, the -1 item. And so it returns it to me as a Lua number, then I convert it to an actual float. And then I put it in my output at whatever my current index is, which is 0. So I've written that, so that should be, yeah, so the first item is now 1. Now, because remember when we called Lua next, it added an item onto the stack. It replaced the key with the current key, with the actual key, and it added that 1.0. So we pop off the value now that we've obtained it, and our stack goes back to where it was. And we do that. We just sit here and loop. And I do some safety stuff here to make sure that I don't pull more values into my output array. So I grab the next one, convert it, pop it, you know, pop the value, make sure I haven't, you know, if I've written the number of floats I need. Get the third one. Now I've read 3 floats, which is the number of floats that they asked me to. So now I've popped, this pop took the value off, which should have been 3.0. So that popped that off. I had pushed, when we came into my routine, I pushed an extra value on the stack, which is the key. I popped that key off to put the stack back where it was when we came into here. So I reset the stack to the state it was when I came in, when it was handed to me. Because again, the important thing here is we don't leak items on the stack.
You actually have a bug.
What's that?
If you fail to read in the number you specified, it will leave an item on the stack. So if you said read in 3 and there was only 2, it's going to leave one of your things on the stack because it'll never ++ index is equal to known floats.
Oh, yeah, you're probably right. Well, that's why you don't always just take my code verbatim. Or does Lua next, the last time you call Lua next, it might pop, does it pop the key?
I don't know if it pops the key when you're using it.
It might. You might want to check that because you may be right, but I think I debugged this and I found that this weird logic was actually the way that the stack always came out right. But you could be right. Anyway, so now we're done. That inside that if popped my key off, so I've set the stack back and I return, and now you can see my position is 1, 2, and 3, which is what's in that list over there. So now I've read the initial position table into a float array, and I pushed the key, the initial position key, it had replaced it with the table. I'm done with that table, so now I could pop the table. Now I want to get the bounding box, which I do that. I push the string bounding box, I get it, and I make sure it's a table. And now what I've got on I pushed the key bounding box here, and it replaced it with this entire table. So now I've got to do that processing twice. I got to do the 3 to floats. I do offset and size. So here my bounding box table is actually on there. I don't know how to represent that, but I'll just call it my bounding box table. It's on there. And then I push the key offset, and then get it. So now I've got my original tables here, my sub-table bounding box is here. My new, I want to start processing that, so I push the offset here. So I've grown the stack a little bit, but it's because I've walked from one table into a sub-table of it. And so I push the string offset, and I say, okay, now I'm saying Lua, I'm calling get table out of the table at -2, so that's this table. So now I'm calling get table, the table I'm working is my bounding box table, and my player table is still sitting down there on the stack below it. I could reference it if I wanted, I just don't need to right now. I could reference it at -3. But anyway, I replace the offset, I say get the table, my key is offset, get it out of the table. It should be another table with 3 floats. So I do that, then now my bounding box offset table is on here. And so now I've pushed 3 tables deep now, and now I call that convert to float thing, and it grabs the bounding box offsets. I pop the offset table. I push the size to get the size table, and I get it, and then I have my float reader grab it, and I pop that size off there, so now I'm back to where I originally was, because I pop the size table off. Now I'm done with my bounding box, so I pop my bounding box table. Now I could have collapsed these into a Lua Pop 2, and it could have got rid of 2 things for me. Just for clarity, I didn't do that. So, or so I could comment I didn't do that. Anyway, so now I push physics settings, and I want to find the physics settings. I get it. Now here, physics settings at the table, but instead of asserting, now up here I said, hey, the type you return better be a table. Down here I said it better be a table or it better be nil. So now, if the physics settings don't exist, the type it returns is nil because it didn't find it. Okay. So I don't want to assert that it's not a table, because if it doesn't exist, it's going to be nil. So I said, if it's nil, or it either shouldn't be there, or if it's there, it should be a table. Now, if it's a table, then I fall in and start processing it. If it wasn't in there, I would bypass all this code. That makes sense? So that's how I'm like, I kind of, yeah, well, you get the idea. That's how I determine if there's no physics settings, I don't run through this code.
Hey, Joe.
Yeah.
Can you mouse over P Lewis 8 and list the members? I'm curious if it lists the stack.
No. Oh, stack and stack.
Stack. So what's if you expand stack?
Oh, you don't want to even mess with that, buddy. Just digging yourself a grave.
Oh, I wanted to see if it would list the actual value, so I can go.
No, like I said,
the drag.
Like I said, these are all uninitialized, and it's just garbage.
Yeah, I was just wondering.
Anyway,
if
so
it's easy to
and you can
debug.
see the pattern repeat itself. Push my string. I want to get the mass. Get it. Ask it to get down the table. Make sure it returns a number because my mass is 10.0. I don't even. Oh, now I did this to show you here. So what I did here is I got rid of the bounding box table. I grabbed the physics settings table. So the physics settings table's on here. And just to show you a different way of doing this, I push the string mass, then I push the string drag, I push the string mass, I get it out of the table, which replaces that with the math. I push the string drag. Now the table's bumped up. Now, so here, when I push math, my table is at -2. But then I push drag, so I'm one farther away from the table, my actual physics settings table. So when I ask for the math, I say, hey, the table's at -2. But then I push another another key onto the stack, and I move everybody down. So now that table on my physics settings table is one more. So I'd say it's at -3, and then I grab my drag, and it replaces it with the drag. So now I've got two values on the stack. I just did it to show that you don't always have to do them in pairs. You can, you could push, you could push and leave, push and leave. But anyway, then I convert. So then I convert my mass, which is at -2. I convert my drag, which is at -1, and then I pop 2. So I eliminated the pop set. So then I pop 2, which is all that, and then I probably pop again, so I could, and then I pop my table off there. Now the thing is if the table wasn't here and it pushed nil onto the stack, I still have to pop nil because it pushed a nil on the stack. And anyway, then I do it against my render settings, so it's all the same.
Hey, Joe.
Yeah.
So if you have a physics setting, your thing assumes that it has both a mass and a drag.
Yeah.
So you couldn't like leave.
You could, well,
Because it would.
you could have default settings for everything.
You'd have, with your code right now, it wouldn't work, right? Because it would cause some
Yeah.
referencing errors.
Yeah.
You try to read.
No, we would push nil.
Then you try to convert nil.
Yeah, it assumes that if you're going to have a physics setting, it's going to have mass and drag. Yes, you're right. And again, you could be more fault tolerant than I am. You could say, oh, try to get the mass. If it's not a number, or if it's not there, use the default mass of 1. Stuff like that. So anyway, so that's big. Any questions on this? So it's basically there. It does the same thing for the sprite color. Then I pop the render settings when I'm done. Then I pop my final player table because I'm done parsing the player table. And then I get the number of stack items, which is now 0 because everything I pushed onto the stack, I pop back off. So my stack is clean. And then I'm done. And then I delete the file contents. I could have deleted it earlier, but I deleted it. All right. And then I have this other table.
I think you have it open in the text editor.
I do, you're right. No. I have this other table over here, somewhere, called monsters, which is just this list of monsters I want in my game, and obviously it's a table of tables, and so I threw in. I started writing this process monsters. It's not all done, but I basically do the same thing. I load the monsters, I load the buffer, start it up, grab my global, which is my monsters, then it's an iterative thing. I see that if you look at the monsters table, the big difference is they're on the tables. I've got a table full of anonymous tables. And so it was just another example. And I don't read anything out of here. I just show you how to iterate. And you should be able to figure out how to iterate over an anonymous table. Oh, I guess I do grab the name. Yeah. Duplicate it. And then here I remove 2. I remove the value. Yeah. So it was just another way of showing you how it worked if you needed more samples. I don't process any of that data. So that's it.
You pop 2 items because you are just going through names.
Well, I pop two items because I pushed a key on there, and then when I call Lua next, it pushes a value. So I pop both those off at the same time and put a new key on there. Or I think that's what I do.
Yeah, that's it. Because Lua next will
initially
populate the key name and will populate the key that comes after the one you put and push a value.
Is that what I do?
Yeah, that's what you're doing.
Okay. Yeah.
But if you are iterating through all the things in the table, will you still pop 2? You will just pop one line.
No.
Oh, I pushed a name, because I want the monster's name. And then, so Lua next added a value on the stack, which was the value. I pushed the key on there. It replaced the key with the key it actually found, the next key. Then it actually added the value. So it added one item to the stack. Then I pushed the string name to find the name. So I added a second item to the stack. That makes sense?
But do we have name in the monster table?
Yeah. It doesn't matter if it's in there or not. I pushed the string name onto the stack. I need to get it off of there. So if I pushed the string name and it wasn't there, it would have replaced name with nil. If there is a name, it replaces it with the value. So, but what happened was, my table was here. I pushed my first key nil. I called Lua next. It replaced me. That was the actual key, which was because it's unnamed as 1. And then it pushed the value at 1, which was the first monster. Then I pushed name to get the name of the monster out of this table. Okay. Then I want to come back and do Lua next again. But in order to do Lua next again, this is where the key is stored. So I have to pop the name I put there and then the value he added there. So I just Lua pop twice. Yeah. So that's basically it. Again, this sample is out there on my GitLab samples thing, so you can look through it. It gives you something to start with. And you can look through the slides too.
Yeah, Joe, you have a, I think it's Lua P call function. I'm just wondering what that does.
So that's what tells right here.
Yeah.
So that's what tells Lua to process. So I loaded the file up here. I load the file into a buffer. I pass that buffer to the Lua state, and then I tell it to process it. And in fact, if there's any code in there, it would actually run the code too.
Mm-hmm.
So you're deleting the file at the end. Can you delete?
I could delete it right after here. Yeah, I think I can delete it here. I don't know completely for sure whether load buffer duplicates the contents or not. You'd probably need to look that up. But just in case, I don't delete it until I've done everything I want with it. So, yeah. So the only other thing, I had one slide here. And yeah, one of the things here that we talk about is one of the downsides is it can be error prone. You have typos, missing fields, too few fields, too many fields, the wrong data type. So my question was, what errors can we recover? What errors do we recover from, and where do we assert and where do we error out? And I asserted on all my stuff, but I think ideally, what you should do is in your code, if you, like, say, are looking for the name of a monster and you push name, and it's not there, you should print it. Say, hey, couldn't find name for this in this table, or if it's the wrong type, name is of wrong type or something. So you should do that.
You could even write Lua files that go through and check if you have a physics setting. Well, then you better have a mass.
Yeah, you can do that.
Little offline.
Yeah. Again, if we have a bad field, can we replace it with default value? So, the question comes down when you're doing this: should we assert? Should we use default values? If the mass isn't in the physics settings, do I just set them all to 1? I don't know. Or do we have debug prints? I think ideally you debug print and then exit out is what you can do. And I just wanted to show you this really quick. Well, I'll go through this last slide. But ideally now what we should be able to do in our engine is say, hey, engine, or so whatever system, create an actor, and here's the Lua file. And it would spit me back an actor. So what it would have to do is consume the Lua file, read all the values out of it, the name, the name, the controller, the initial position. Once it's found everything it needs, then it calls create actor and creates it and returns you that. So, and then I put this down here. I don't even remember what it meant, but evidently there are some Visual Studio plugins available that make Lua nice in Visual Studio. I have no idea. Huh?
Syntax highlighting.
Probably that, yeah. So,
Execution support, so you can actually run them.
yeah. So,
Is there a limit to how big that stack can get?
I don't know, honestly. Probably pretty big, but.
What if you're like,
Hard
what if
drive,
you're loading
RAM
like a
memory.
huge?
So when you initially load it, if you push a table, in theory, there's only one thing on the stack, no matter how big that table is. I'm assuming that the table lives somewhere else in
Like,
memory.
It's like super nested.
Yeah.
Then it can get pretty big.
Yeah,
Yeah.
I think it's probably pushing some kind of ID or pointer, and
Yeah.
then it knows.
It probably
what
can
it
get
is.
pretty big, yeah. I mean, like I said, we used Lua for all of our AI and scripting and Infinity, and I think we had Lua files that got up near a megabyte or something, pretty big. And we processed them okay. It's supposed to be, Lua's supposed to be small, light, and efficient, so, yeah. I don't think there's anything you can do that. But the one thing I wanted to show you really quick, and I'll let you go, is, so if I go back,
Go write a wild true push to stack thing
do I
and
have
see
it
when
here?
when it crashes.
yeah, you could do that. Let's see here. I see one there. So, just a second. So if I run Lua, so I've aliased, so if I run Lua, that's their little scripting language, their interpreter. So I can run Lua, I can run my player.dat Lua through it, and it doesn't do anything because there's no code in there to run. There's nothing to print. Now if I go back over here to my player, this thing here, I think that's the right one, and I just do something like that, see if that works.
That should throw an error.
So that should throw an error because that's an illegal thing. I go back over here and do that again. Yeah, now it says, hey, there was a syntax error in your data table. So as you guys develop this, you probably benefit to going out and running, having a window opener somewhere and running your data table through Lua. Now ideally you could probably create something in Visual Studio that did it for you, like a shell command or something. But yeah, this will at least tell you whether the data table is correct. Because when you run the P call, it's not going to do it nicely. It's probably just going to crap out and you're not going to know where or why. So at least here it says, hey, I expected on line 4, at line 4, I expected a bracket to close the bracket at line 3. So just remember that, because I always get students that ping me on Slack, go, oh, it's not working. And I'm like, check your table. So. Anyway, that's it. You'll have to download Lua, and then the samples are there's a Lua in my samples group. So, and I think you guys get the point of the assignment,
So our game static is
Yeah.
What? I mean,
You could do Dell now, but it's just easier. Before we get started on today's stuff, nada. Did our class shrink? Or is it just too long of a walk for people? All right, we'll get going then. Everybody's quiet. Everybody tired? You have a big project or something, or just
It's been a long day.
it's been a long day? Okay, well, we'll try to make it quick. I actually have a head cold, so I'm not feeling very well either. I was going to cancel class, but I'm like, no, they won't want that. They love to learn.
Dashing my hopes.
There's a lot to learn. I had a chance to talk with a few recruiters and that about everything you guys need to know and what they test, quiz you on, and I'm like, man, there's just a lot of stuff. So anyway, we'll get going. But today's stuff shouldn't be that bad. At least the lectures. Fortunately, for me, this is one of those where there's a little less lecturing and more homework. And the homework's not bad, I don't think. Did y'all get your smart and weak pointers done, working really well?
Yes.
Bug free? That's a good accomplishment, I think. Like I said, I know a lot of guys that I worked with at other places that would say, well, they probably couldn't implement it. So, all right. So today we're going to talk a little bit about driving our game and engine via external data, and this is something we talked about like in the first class, that this is an ideal property of a game engine, you know, and you guys have all worked in Unreal and Unity and that, so you understand that, you know, the code, the engine doesn't do much without us telling it to do it. And, you know, you've also worked in, you know, you've also working on a variety of projects, and you can see that Unreal or Unity or Lumberyard, you know, they'll work for, you know, you guys could make two completely different games with the same game engine because you drive it with different data sets. And I don't know if you've ever played with, like with Unreal, we have quite a few samples. We have samples all the way from a Match 3 game to, you know, like Candy Crush, all the way up to Unreal Tournament. So a lot of things we can do with it. And 2D side scrollers, I think we've got a 2D platformer. So anyway, you know, depending on, you want to make an engine that's a goal of an engine, is to make any assumptions, as few assumptions as possible about what it's doing, what kind of game it's made. And you know, when we did our first assignment, our first monster chase, you know, and I kind of got a chance to see your guys' code, it's like, well, everything was pretty much hard-coded. Most people did it that way, and I kind of moved you down that path anyway, just so you would do it. So that down the road, as you guys, we get towards probably this lecture and the next few more, you'll be like, wow, I can, you know, I can see the difference now between just writing a monster chase game and writing some piece of technology I can create it on. So anyway, so yeah, so we're gonna learn a little bit about how to do that. Now, you know, in Unreal, you drive it with our data. We've got two kind. I didn't put a slide in here, so I'll talk about it now. But we've got. I kind of break them down into two kind of data sets. We have a lot of different kinds of data that drive our engine. You know, like we have geometry out of whatever you build your geometry in. We have textures, stuff like that, audio assets, and those are kind of core assets that build it. But then we've got other kind of assets that I kind of break out into like the gameplay iterative assets, like maybe blueprints. If you're working with Unreal, you know, you build blueprints to control logic. You know, and that's kind of what we're trying to get at. You know, you can go into blueprints and pick an asset like a player and drop them in. You know, and you put him in there and you set all of his properties, and you fire up the engine, and boop, a guy. You know, there can be a guy standing there. I think there's actually, I don't know if you've shown, I don't know if you've ever seen it, but there's a default like guy that we kind of use it for testing. And, you know, so you can set a few properties to him. You drop him in there, you set a few properties, and boom, he shows up in the world. You know, and you know that's what I mean. Now we can't. That's your ideal thing. That gives everybody power to help develop the game. It allows you to come at it from multiple vectors, you might say, or multiple people. In the old days, when we developed games, if a designer wanted something, he went and tapped the programmer on the shoulder and said, no, make that guy go faster, you know, and that's what the programmer did. He went in into some CPP file and changed the speed or something in any way. But it became just financially, I guess you'd say, not viable. You know, you can't. We got better things for programmers to do. If we put enough programmers on it that we could programmatically generate the game, it would be cost ineffective. And so this allows designers to do their work. You know, well, I got a slide in here. It allows them to do. You know, you don't have to. If you've ever, has anybody ever tweaked Unreal code? I don't know if you ever do, but if you ever tweak the wrong like header file, you should go to lunch. But you know, come back to wait for it to build. And so there's this iteration time that we want to get away from. Iterating blueprints, if they're not nativized, is a lot quicker. You know, you can make a change and see it right there live in the editor. And so it allows you to iterate gameplay. The more we can iterate gameplay, the better games become. You know, it's one of I think the things that really help indie developers is they probably, you know, when I was at Disney, we were always driven. Our games came out at the end of before the end of financial quarters, so that they could book the income from it. And so, but I think my guess is with a lot of indie games, they work on a game until it's polished, and that's I think one of the ways you get these fun little indie games. Anyway, so we'll go on and we'll start. I think you guys all get what I mean. I guess I don't get that. Oh, gotta plug my thing in. Hold on a So, you know, I kind of drew this thing to kind of give you a visual idea of what I'm talking about. So, you know, we've talked a lot about this thing here. Here's our game as far as the code. We've got our engine code, we've got our game code, and our game systems. And that, you compile these together, that comprise our game. So ideally what we want to do is we got some game data out there that we want to feed it, and then out pops, you know, I put my picture, my two little guys up there, didn't have anything else. And so that's what we want to do. We don't want to have to go in and, you know, we want that over there to generate that. You know, and I threw this in here, why create, I didn't even finish it, you know, why create data-driven games. So I just thought, well, we'll spitball and talk about it. And I thought you guys might have ideas, but you guys are really quiet. So anyway, so we're gonna look at kind of a, you know, I can't all go out, you know, we could talk about it, and then I could go back and post your assignments, like recreate blueprints, you know, and assignment due, you know, sometime in 2018, you know, as a team. We can't do that. So I wanted to boil it down to something that you guys can wrap your head around, what you can do in an assignment. So it's not, may not be the equivalent of what blueprints does or what you used to, but it's something that we can do and get done in an assignment kind of time frame. And mainly what it teaches you is how do we do it. A lot of what you learn is not so much the front end, the input side, the blueprints or whatever we do, but it teaches you the back end. How do I code for data-driven input? And so that's what we're really going to do today. So so really, you know, I kind of started out to look, I looked at what do we have already to work with. And so I kind of, you know, I kind of looked at, well, primarily what we create right now, the only thing we really have the ability to create in our game is a game object or an actor, what, you know, we talked about for the last several weeks. So I'm like, okay, here's some of the fields we need in order to really flush out a game object in our world, or an actor, or whatever you want to call it. You know, the name of it, its initial position in the world, maybe what's the initial controller, or what AI script are we starting on it, and then, you know, we talked a lot about this spatial information, you know, from its position in the world, where is its volume and how big is it? So where's the, you know, where's the point of its, you know, when I talked about this, so, you know, my position in the world would be down there, but what does my volume, what volume do I take up relative to that? And so, you know, we talked about having an offset and a size, or you could quantify it as corners or whatever. But, and then you know, we talked, and it's like, okay, if I want to apply physics to it, I need a mass and a drag, and then if I want to apply sprites to it, you know, I need my texture and maybe a color if I want to color changing. And you know, and here's some possible values for those. And obviously, right now, most of you probably, there's some code you've got where these things sit in, you know, character strings, vector 3s, whatever, and that's what we have right now, and that's what we drive from the game, and we want to get away from that. So, you know, ideally what we want to do is we want to say, hey, you know, instead of doing it in code, I want to, you know, put it in some human readable, human editable format that the game, compiling the game is not dependent on. You know, what I'd like to do is have some you know, description of it that I can tweak, and then somewhere in my game I just say, hey, engine, create an actor, and here's some piece of data, some data file that I tell you, you know, hey, engine, create an actor, and here's the name of the file, and it goes out, the engine goes out and grabs this, brings it back in, and when it's done, you know, my robot pops into the world, and, you know, he exists now in as far as my game is concerned. So that's kind of what we're getting at. That makes sense. Everybody kind of knows what I'm getting at. I haven't lost anybody yet, which hopefully not. So, you know, I'm like, well, how do we do this? What do we do over here? How do we, what format should this be in? And you know, and I've kind of given half of it away. We want it to be human editable. We'd like something that you know, we don't want, you know, we could do it in binary format. You know, we could have some tool like blueprints that we go in and edit all the fields, and then we click a button and it exports some data file that the game recognizes. But I just, you know, we could do, so that's what I call a custom format binary file. You know, and the cons here, you know, the pros here for one thing about binary files is they're really fast to load. We don't have to, you know, like you've seen with the texture for the texture for your sprites, you just load the whole thing into memory, and and pass it off to the renderer, and that, or to the glib to use, and it's kind of instantaneous. But the cons here is, obviously if the data looks like, and I just threw some random numbers in there to look like binary data, obviously the couple of downsides to that is, well, I can't really go and tweak that file if I want to change something. I'd have to load it back into an editor and, play around with it, fix it, and then write it back out, which, so it's not easily tweakable, not quickly tweakable, and then, it require me creating and maintaining some tools, like blueprints, something like blueprints to do the work. And obviously, maybe in the end that's the best solution, but for our goals or for some of our stuff, maybe that's not. So, I looked at, okay, well, one other thing we could do is we could do some kind of custom format text files, which is a way, when we finally got, I've been doing this forever, so when we finally got the idea, like, hey, we shouldn't just be doing all this in code. We should have some data files out there, some text files we can tweak and, iterate faster. And so we just, instead of, recompiling the game, we just rerun it and it reloads the data file. And so we started creating, our kind of own text files, and, and obviously the upside here is it's user editable. If I want to change the texture on Joe here, I can just go into this file and change the name of the texture from goodguy.dds to robotguy.dds. Now some of the cons are, I'd have to write a parser. I have to have some way of converting this text file into usable information, which would be parsing it. I could say, oh, the first line in the file has to be a text string that's the name, and the next one has to be, 3 floats that are the initial position, and and so I'd have to write a parser, and the problem with here would be, well, the format's not easily distinguishable. I can't just look at this and say, oh, the third line is the controller to use, because I may give a controller a funky name and nobody understands it. And of course, there's human error issues here. What if one of the things I'm always doing, I don't know how I do it, is I'll be doing something and some part of my job, and I'll start typing and realize that some other window has focus, and I just type my password into the Epic Slack channel or something, I mean, we've probably all done that, right? delete, delete, delete. Anyway, so it'd be very easily to want to make a quick change and misspell something or change the format. But one of the other cons about parsing text files is it takes time. You don't just load it and splat it into memory and hand it off to somebody, but you got to load it into memory and then walk through it. And again, we've already talked about string compare is expensive. It's time consuming. And obviously, this one isn't bad. But if you start out, what happens in game development is you start out with a workable system. If you build any kind of system and it doesn't work, it becomes quickly deprecated or no longer used. If you write a system like this and it becomes usable, it quickly blows up to the point where it's you're like, wow, this is way outside what my the scope of what I originally designed was. But you gave the designers or the producers or the artists, whatever, something that they could quickly, you give a designer something that allows them to tweak and iterate gameplay, and they're gonna use it, and so anyway, so this, what I'm getting at is this file is small here, but when we did this, we started out with something that was about this size, and we ended up with files that were like literally hundreds of Ks big, 500-600 K text files that described AI, and so. Yeah, so anyway, so what we're going to do is we're going to do a hybrid, and I didn't have a good segue into it, but we're going to use Lua, and the reason why is it has the best of the bottom, and it doesn't really take a lot from the top. It is kind of fast. We'll talk about one of the things they say about Lua is that the Lua, down here, if we wrote a parser for this, we probably would write it, and we're probably not the best parser writers in the world, but the Lua guys tell us, well, their parser is pretty fast. Anyway, so we're going to use Lua. And one of the things is, the pros here is it's user editable, which we want. Another pro is we don't have to write a parser because Lua provides one. The format is documented and distinguishable. And if you look at this is actual, we're going to focus on Has anybody ever used Lua before? Okay, one person, well, we'll be fine. This is right here is entirely Lua data. This is not, there's no Lua code here. But it's Lua data, and Lua is kind of cool in the way it kind of allows us to do things in a way. I've defined my my data here in a way that you can read. You know, it's key value pairs, and we'll get to it later. But all Lua data is tables. They're all key value pairs, almost always, except for even this down here. You know, you can see the keys and values here. Key is value, key and value. You know, key and value. This is a value for player. Key and value, key and value, key and value. And these are actually three anonymously keyed values. Everybody familiar with key value? You know, everybody works with it. We're all programmers. So anyway, so this solves. This is a happy medium. I think we used it. We used it at Disney, and it worked really well. In fact, it worked so well, like I said, it blew up to the point where it got a little unwieldy, but it was because it worked very well. You know, and modern engines now, you know, like Unreal and Unity they've progressed from big and and some of the like Valve engine, Source, okay, Source, and there's another few. Anyway, they've progressed from. They probably progressed from this all the way up to being able to like use native C++ code. But for describing things, Lua works really well, you know, and so you know you could use C data structures. But anyway, this is what we're going to do. So so what I'm going to do here is I'm going to try to walk. You know, Lua is a language. You know, it's a interpreted language, but it is a programming language, and so it's got its full syntax of code you can run and logic and everything, and you probably classes up here that take a semester and teach Lua. Well, again, we don't have time for that, so this is Joe's 2-hour explanation of what Lua is and the data side. And another reason I do this in Lua is you guys are going to spend quite a bit of time next semester, I believe. JP always changes things, but building a rendering system and a tools pipeline using Lua. And so this will be your first step into it. I'm kind of helping you get your feet wet. And we could use something different, so you learn Python and Lua, but I think this works better because it gives you some introduction to it, and everything you do here can be kind of be parallel to other interpreted languages. And most of you should be familiar with the difference between it.
I thought I was hoping you'd finish your thought.
What's that? Oh, I was going to say most of you should know the difference between an interpreted and a nativized language. C++ is what we call a nativized language because it's compiled into native code that the machine runs. Lua is not. Lua, and I'll get to it in a minute, Lua actually interprets this, and under the hood, it loads this at runtime. Every time if you run a Lua program over and over and over again, it just converts the Lua code to byte code and runs it on the system.
So, do you know of any engine that hits a midpoint between both the types of things, like with the text-based and database?
I don't. Most engines, honestly, like I said, most engines have gotten to the point where they have something like Blueprints, a graphic editor, and then they have the ability to run. You can write C++ code or C# code or something like that. So that's kind of the way they've gone. But I haven't experienced. I don't know what Lumberyard does. If any of you guys working with Lumberyard, huh? Okay, yeah, most of them have gone that way.
Do blueprints get compiled into game code?
So no, they can be. So we have a thing called nativizing blueprints that converts them to C++ that then gets compiled beforehand, and then it runs like native code. It runs just like the code you would write. But if you don't nativize it, it's interpreted.
Because you're saying that parsing can take a long time.
Yeah, it can.
So if you can like when you go gold or something with the game, you just say tick a property, and then it will probably take all the stuff and hard code it into your game and make a game.
Yeah.
So
Yes.
You don't have to parse when you're running.
Right. Exactly. Yeah. So actually, and I just found this out the other day. nativizing blueprints, which means converting them to C++ code and compiling them, was only available, I think it was experimental in 4.12, and then become usable. It was in 4.12 experimentally and wasn't documented, and then in 4.13 it became documented and usable, supported, I guess is what you'd say. So it's relatively new to Unreal. Ideally, like you'd say, when you get right down to the 11th hour, you would nativize all your blueprints. If you may have blueprints that control UI that you're like, why bother? It's a blueprint that controls scrolling up and down in a menu or highlighting items in a menu or something. You could do it, why bother? Hopefully the whole idea there is when you get to gold and you nativize the blueprints that they run just the same. That's the onus is on us. So
I'm going to say, well, it would also be nice to still keep some kind of data engine like that, because it would make user-generated content really easy.
exactly, yeah. That's a good point. Something like this, if you could have your GUI spit out something that was still human editable, then it would make the user-generated content so great. And that's one thing that made Minecraft so powerful was, well, Minecraft was written in Java, so you could easily go in and it was interpreted. So all of the source was there basically, and so you could go in and tweak things and change things, and that's where all the Minecraft mods came from. And now that Microsoft has bought it, I think they're moving away. When they created a pocket version, I think they called, of Minecraft, which was to run on like your phones and that, and because you didn't have enough power there to run interpreted Java at a decent frame rate, they converted it all to be a C++ game, and now that's what they're moving to Windows 10, and of course now that it's nativized, none of the mods work. So you're right, that when you have something like this. So ideally, and again, I guess to talk to both your points is, you probably want something like Blueprints that allows someone to sit down with a GUI and change things, so that you can validate the inputs and then write out something like this. And that way, you have a phase of your project that says, hey, all of this file is syntactically correct for what I expect to read. And you'll see that later, because we actually have to use, unfortunately there's not a lot of magic behind the hood. We have to do it ourselves. But it does, there's still steps we have to do programmatically that we would like to not have to do. But again, if anybody wants to sit down and recreate something like Blueprints by due date next Friday, go ahead. But I think you're going to have enough trouble just with what we're going to do here. So, but ideally, like I said, that's what you'd probably do, is you might create a great system where you can describe, have Lua data that describes how the characters that come into your game, and maybe even you'll see down the road, you can write Lua code that you can call from C++ to have it execute, and that could be like your AI and stuff. And anyway, there's, like I said, loads of stuff we can do, but we have 1 3-hour class to get started on it, and then it's probably something you may want to use. Like I said, you'll use it next semester for JP's class quite a bit, and then you might even use it for Shane's. I don't know. So anyway, so yeah. So we've kind of talked about it, but I threw this in here. What is Lua? And I just took it from Lua.org, and they touted it as a powerful, fast, lightweight, embeddable scripting language. And that's another reason that we picked Lua originally, and why we're using it now is because it was designed to be embeddable. That's what they give you. Is they give you something that you can compile into your program and access it via an API. So yeah, and we're going to get through all this, but Lua it's dynamically typed, which is good and bad. I hate being a guy that learned C and then moved on to C++ when it was invented. I hate dynamically typed languages. They just, I love the strict type checking of C++. Got a variable, it's an int. Should always be an int. Shouldn't change to a string because I set it equal to a string. But that's the way dynamically typed languages work. It does have automatic memory management, garbage collection, so which is good. We don't have to worry about memory leaks, so that's another upside. So anyway, like I said, we just some cheesy background stuff here. And so yeah, so why did we choose it? What are some good qualities for us? It's embeddable. Like I said, it's made to do what we want. We're not forcing something. We're not like saying, hey, maybe we can take this, Python interpreter or whatever and jackhammer it into our code base. It's very easy to do. Yeah, and it's portable. You know, it can be compiled into, I don't know of any system I've ever worked on where you can't, platform where you don't have the Lua code that you can compile and link into your stuff. So, you know, and they say it's powerful. It is fast and it's small. You know, which is generally three things we like. We like, you know, it doesn't take a lot of memory. We tried something when I think it was when we started Infinity, for our configuration stuff. Someone got the bright idea to embed SQL. What's the small version of it?
SQLite.
SQLite. And they embedded SQLite into our engine, and it worked great for storing configuration and all this other information. We got down to the 11th hour, and its memory management, its memory allocation and usage patterns was horrible. So we had to cut it out, and we went to Lua. Lua held up a little bit, or better, a lot better. And then it's free. You know, it's you can just take it and use it. You don't pay anybody. So, you know, like I said, it's not perfect. There's a time cost compared to native code, binary data. It is fairly easy to make errors, but it generally reports them well. And again, it's not the only choice, but its properties fit our needs are really good, and we've talked about some of the choices. So we're going to use it. We're going to do it. And again, it's less important here about what language we choose and more about just learning on the back end how we might code to be data driven. So, if anybody is any like, you always get one of those persons with Python's so much better, or you know some other new language. I like them both. Yeah. What are the new ones like F? I don't even know what some of the newer languages is. Microsoft keeps inventing them just because they. And they're an F# or something, or yeah. And then there's Go. You know, so
Go's like a, not really, it's not interpreted.
Yeah,
Isn't
but
it
it's.
compile?
I've never used it.
You're talking about Swift?
Go. Google's Go. I've never used it. I don't know if it's better or what. So anyway, we're going to use this. We're starting with it. Okay. Anyway, we already know this. Other notes on it. It's runtime interpreted. You know, we're not running process or again native code. It's garbage collected, which is good. One thing that's cool here is Lua scripts. You know, we can run them from the command line via Lua, and we're going to do that to validate some of our stuff. And you know, well, two things here. Lua scripts can be run from the command line, or we can execute Lua scripts from C++, C++ code via the embedded Lua library pack. And that's what we're going to talk about today. So if something there doesn't really make sense, we'll get to it. And then the one thing I put in red here is Lua variables are dynamically typed. Variables don't have a type, if that makes sense. If I create a variable, myvar in Lua, and you know, if I do it in C++, I have to tell what type it is, int, float, whatever, for the compiler is met. In Lua, you can just say, I got a local variable called myData. It has no type until you set it equal to something. So the value has the type, not the variable. And that gets important because it actually becomes a crimp on our side. It makes our job a little bit harder. So what are we going to use it for today? We're going to use Lua data to detail the inputs for creating an actor in our engine. And here's a Lua file I created, started to define a player in my game, or the player I call it. And I just this will start to make more sense as we get through this. But again, I think I have a slide in here, but all data, all Lua data is a table, and a table of key value pairs, and themselves are, you know, a table itself is a value to a key, so where the key. So anyway, like I said, I was telling you before, here's the key and here's the value, and the value of that type, that data type is a table, and you know, the table has a bunch of things in it, which is this and this and this and this. And this. And then this item in here is a table too. This is the key and the value is a table, and it's a table with one anonymous item in it. That's how it looks to the interpreter, and this will make more sense later. So anyway, this is a script or a Lua data table I created to define the inputs I needed to create a player actor in my game. I've got a name, a class, you know, I just kind of made that up. What controller I want on it. Here I want the input controller, which is the controller that takes user input and makes the thing move. I've got an initial position for it, and again, my initial position is the key, and the value is a table of 3 anonymous values. And then I have a bounding box table, which is has 2 values, which are key. The key is offset, and then the value is the offset from the origin or from its position where its bounding box is, and then the other one is the size of it. So that's and we can expand this, and you could write it differently. This is just what I chose. This is something I typed up for my sample, and it's going to be up to you how you do yours. And it's kind of always sad when I look at the assignments and 90% of them just copied my stuff. I'm like, well, where's the experimentation? Come up with something better than me. Not that hard. All right. Anyway, so that's what we're going to be dealing with. So this is some valid Lua data, and we're going to parse it and use the information in it to create our actor. Instead of having it all in code, it's all in this player.lua, I call it, and we're going to read it in and process it and create a player. All right, and again here, there's two ways to use Lua. One is there's a Lua command line interpreter called Lua.exe. Well, it's not called this Lua.exe anymore, but we can use it to execute a script. And then the other way to use it is embed the core Lua code into your application and do things with it via the API they provide, and that's what we're going to do. And I just wanted to show you here, just so you knew what I was talking about. I put a quick sample here today. Kind of cheesy, but here's my, can't work with any languages without doing hello world. So I have this hello world.lua script, and I've downloaded. You guys are going to want to grab the interpreter, but you just I tell Lua and run my script, and it spits out hello world like we would expect it to. I always forget. Usually what I do is I have this script in here, and then I have another one that prints something else, and I run the other. Yeah. But I forgot to do that. So, all right. So that's the first way. And the reason I wanted to do that is one of the cool things we'll do, and I'll try to show you before the end of class, is one of the things we can do is when we create these Lua data tables, like this, like I talked about, in order for Lua to parse this and give me the information out of it, it has to be valid Lua data. And so one thing you can do during your development cycle is, as you create your own version of whatever your script is, your Lua script is, to define your player, you can run it through the Lua executable, and it will complain if there's any syntactical errors in the file. So I always get students that say, "Oh, it's just not working. I'm getting this error," and I says, "Is your script valid? Did you run your player.lua or whatever you called it through Lua, the executable, the command line utility?" And they're like, hear from them, they're like, "Oh, that was it, I forgot." So you're going to want to do that. So because, like I said, if I left out a comma somewhere or an equal sign or put a pound sign in here inadvertently, and I told the Lua parser from my code, I told the Lua parser to read it in, it doesn't handle it as gracefully in code. You actually have to ask it, hey, you have to get an error from it, and it gets a little ugly. So you want to save yourself some time, you'll want to run this through, to run your script. And what we did at Disney when we used it is, in our build process to build our assets, we would run all our data scripts through the Lua interpreter command line and capture the errors. And if there was an error, we would halt our build and say, hey, this data is not going to work in the engine. Something got to happen sometimes. Anyway, so yeah, so what are we going to do, or how are we going to do it? So we're going to embed the core Lua library into our application. Then we're going to load a Lua file describing the inputs for creating a particular game actor, which is this. And then we're going to use the Lua API to extract the data, which is, pretty much this, and this. So we're going to pull in all this information. Once it's all correct, then we're going to say, oh, I've got all the information I need to send to my actual create actor routine to create an actor. And yeah, then we're going to use the data to create a new actor in our game. So, and I just threw this in here, I don't know why. So this is what I did before. Well, I don't know why I had to point this out, but here's the one thing is, again, I don't know why it's in there, but what Lua is they've got this Lua kind of core code that is Lua, the interpreter and everything. And to build the Lua.exe that I run, they actually just wrap it with a very thin wrapper that loads the file and passes it to the interpreter. And so we get all that code here, and in a library that I built the libraries for you. There's a sample. They should be out. Did I check the? Yeah, I've put up in my samples a thing called Lua, and one of the things in there is the libraries. And so anyway, so I just threw this in here. So what we're going to do in our thing is we're going to embed those core libraries via this library, or the core code through a library I created, and then we're going to make a call to Lua to tell it to do things, and it's just basically the same as what the Lua interpreter would do. So yeah, that explains. But anyway, so I just threw this in here so that you know what's out there. So all of this stuff, you know, you'll find out there in my Lua sample all of this stuff here, the header files, and then the libraries, and you know, you got to do what you did before, and I put them up there because people always forget it. You know, oh, I forgot to add the, you know, you got to add the necessary paths to your VS project settings, like your include paths for your header files and your include paths for your libraries, and then you need to link in the appropriate libraries, you know, down here depending on the build type. And I just pointed out here. I think you can include Lua.hpp in all your CPP code, and it drags in all of the stuff it needs. You know, unlike what we do, where everything we create has a header file, where you constantly include what you use, we call it. With Lua, they've got one master header file that includes in their subsets and that stuff. So you're basically going to do like you did with Jula. You're going to get it linking into your game. And then we're going to work with the Lua through what's called the C API. And it's C, not C++ compatible. I don't know what their thing was, but it's pretty usable once you get the hang of it. But when I explain it to you, there's gonna be some, you know, thought bubbles and what. So I'm trying to work through the basic stuff and the most important stuff of working with the Lua API to do what we need to do. There's a lot more you can do with it. There is documentation out there for the functions that we talk about, but I'm going to try to walk you through the ones that work for us. So, so that's what we're going to do now, and this is what you'll need to know in order to do your assignment. So, any questions up to this point? Pretty dumb basic stuff. All right. So the first thing I want to point out. And you'll see it. I have a couple samples we'll work through here. There's a thing called the Lua state. And Lua internally maintains no global variables. It maintains the internal state of the Lua interpreter in this structure of the type Lua state. And so when we initialize Lua, it gives us an instance of this structure. And then every time we make a Lua call, we pass in this structure back to it. And that way, what that allows it to do, it allows the API to be reentrant and allows multiple instances of it in multi-threaded code, because each thread can have its own instance. So it makes it thread safe. So it makes it a little more work on our part, but it does make it reentrant and thread safe. So that if you have two threads trying to ask, because we only have one library out there, one core library, so you can have two threads working with it at the same time, and they don't cause confusion between them by Lua using global variables and keep, you know, it doesn't keep track of anything internally. You pass in the state and it goes, oh, your version or whatever you're doing is in this state, and I'll continue to do the work you want. And then another thread can come in and it's like, oh, you're doing something totally different, but all of your state information is in this Lua state. And so pretty easy. I know you might be confused, but we'll get it once. And then we just need to remember that for most API calls, it's the first parameter we pass in. And you'll get used to it, you'll forget you even do it. So here's one that's important, the Lua stack. Lua uses this, and I call it an abstract stack, to pass data between our code and Lua. And it works like a stack does. You push things onto the stack and it builds up, and then you can pop things off and that. And the problem here is, the reason why they do this is, C is statically typed, I guess you'd call it. The data has a type. Lua is dynamically typed. So it's really hard to create Lua APIs that work with C's. It's really hard, it was hard for them to create a C API for working with a dynamic language, because the API, whenever you define a function, it needs to have the exact types. So they're like, well, we can't do that. So what they do is, when they need to send some data to, when they need to ask Lua to do something, they tell it to push things on the stack, and then they call a function, and the function expects certain things to be on the stack. And we don't have direct access to the stack. It's abstract, so as you'll see later, I can push a table onto it, and then I can push a string onto it. We don't care internally. Well, when I pushed the table onto it, did it push the whole table? Did it fill push 1,000 bytes onto it? What did that? We don't care. All we need to know is we pushed a table onto it, and then we maybe pushed a string onto it. And you'll see what I mean, Dan. I know that's confusing, but but that's how we get inputs into Lua without Lua having to define functions that take C types. And then I just read it here. Yeah, like I said, it's primarily to hold Lua variables and information we want. When we call a function, it expects certain things. It expects certain inputs to be in certain positions on the stack. And then I put it down here like some C API functions will push values onto the stack, and then so basically to kind of wrap, and then some C API functions, when we call them, so what we'll do is we may push a value onto the stack or tell Lua to do it, and then we'll call a Lua function to do some work for us, and what it will do is it will take the item off the top of the stack that's your input to tell it what to do. For example, if we want it to look something up in a table by key, we would push the table onto the stack, then we push the key onto the stack, and we say, hey, Lua, get that key out of the table. And what it will do is it will take the key, look it up in the table, and replace that top stack entry with the value for that key. And so then we have to grab that off of the stack. And you'll see it, but that's the way it works. So one of the things you're going to have to get good at is understanding for all these functions, and they're documented. Okay, what do I have to put on the stack, and then will it is it going to add a value to the stack, or is it going to replace a value on the stack? And the documentation will tell you, and so does my and that's why I went through a lot of these samples, is kind of to help you get your head around what we're going to do here. So again, it might be a little confusing now, but I wanted to introduce you to it, and then when you'll see it, you'll understand what I'm talking about. So it's a LIFO stack, last in first out. So we're always we push and pop off the top. There's no insertion. We may reference indices into the stack, but we can't directly access like the third item in the stack. Yeah. So and then here's the thing I hate is stack indexes are negative. So if I push something on, the way it works is. And I don't know why they did this, and it bothers my brain. So if you look at their abstract stack, it's just a stack. The stack pointer, and we don't have access to it, we just say whatever the current stack pointer is the next empty slot on the stack. So there may be some down here we don't know about. And if we push an item on the stack, it puts it where the stack points to, whatever I pushed, and then it moves the stack pointer. And then if I want to reference what I just pushed on the stack, that's at location index -1. And you'll see that a lot in the code I show you here in a second. And so here's just some, these aren't very good samples, but just kind of show you the API. So here's, I'm just pushing a string onto the stack. So again, what I talked about is I'm always passing in my Lua state. So I say, hey, for some reason, and we don't know yet why I'm doing this, but I'm probably going to ask it to look up the drag in my table. So I'm going to push the string drag onto the stack, and I just tell it push it on the stack, and it does all the work to put that value on the stack. And then here's just these are bad examples, but here's here's some. Well, let's ignore that one. But here's one where I'm saying, hey, I called a function, and so maybe here I'm looking up So here's, I'm probably pushing the drag onto the stack as a key. I'm telling Lua, hey, look up that key in the table that's at index -3. And we're gonna go through this more, so don't get confused. But basically what I did is at some point, my stack pointer pointed here. And at some point I pushed a table onto the stack, which was probably my physics info. And then I probably pushed some other thing, I don't know why. And then I pushed the text drag onto the stack. Now my stack pointer's here. So the string I pushed onto the stack is -1. There's something at -2, I don't know what it is. And then my table is at -3. And we'll talk a lot more about this later, but I'm telling Lua, hey, get a value out of the table, and this is what's weird, is the index we pass to it here is where's the table at in the stack, and my table's at -3, so I pass in -3. But the get table function, and you'd have to read the documentation to understand this, expects the key for what we want to look up in the table is implied to be at this slot, okay? So I say, hey, get out of the table, assuming my key is the last item I pushed, reference the table at the -3 entry in the stack, and get that value out of the table, whatever the value is associated with key drag. And what it's going to do is it's going to replace that value there with whatever the drag is. Then down here I'm saying, hey, I want convert whatever this index is of the stack to a number. And so that number is sitting on the stack. And I want to convert it to a number and return it to me. And we'll go through a bunch of these. These are kind of the things I was going to talk about. Again, it'll get really confusing